Hello and welcome to our today's MERLIC 5.2 release webinar. My name is Christoph, and me and Gaertner will show you the newest features of MERLIC 5.2. As always, if you have questions, use the chat function in the webinar meanwhile and ask your questions and let us know what you're thinking or what your questions are. And now let's directly dive into the new features. The first outstanding feature I want to introduce is the detect anomalies in the global context. Here you can see a front end of juice bottles which shows any kind of anomalies. With this new tool, you can detect all kinds of anomalies. That means the local anomalies and as well the logical anomalies. For more details, I invite you to have a look at our technology video for how to use GCAD. This new tool is tailored to the use with bigger data sets. Later, more to that. The training for this classifier is done in the deep learning tool, and afterwards you can directly execute it in MERLIC. And for give you a good step into this technology, we're also providing a new example which called detect anomalies of juice bottles, what we can see here on our left side as well. So some of you might ask, wasn't anomaly detection not a feature of MERLIC 5.0? Yes, it was. But we improved this technology and add a second tool which detects anomaly. And now I will show you what are the difference, because both of these tools have use cases you can solve with. So if we're talking about the existing detect anomalies, for that technology or for that tool, you only need a handful of good images. You can train it directly in the MERLIC creator, and it detects unknown features, so more or less the local branch. If we compare this with a new feature, for the new feature, you need more of good images for the training. We said 100 to 300 images will lead to a good result, and you train this classifier within the deep learning tool. It detects unknown features like the existing anomaly detection, but in addition, it compares also learned features, its position, and the count of these features. So this means really it can detect every kind of anomaly. And now let's have a look how this looks like in MERLIC, or the workflow in MERLIC. We have the image acquisition done in MERLIC, the pre-processing. Afterwards, you take your data set, transfer it to the deep learning tool, train and evaluate your classifier, and then you can copy it directly to MERLIC and execute it in MERLIC. Jan later will show you how this really works. The next cool features are our easy parameters for the camera configuration. Here you can see our image source manager and a completely new tab which called the easy parameters. It contains more or less all necessary or common parameters you need for setting up your camera. This makes it very easy and very fast to set up. On the other side, it's not necessary for you to browse hundreds of standard parameters like before. But nice to know for you, we don't cut this possibility, so we add the usability. So if you need one parameter which is not shown in the easy parameter, you still can use the standard parameters out of the database. And an additional point for that, for the easy parameters, is all easy parameters are stored automatically persistent in the pers file. Maybe this is a little bit deeper knowledge. So you need a persistent parameter to save the parameters within MERLIC. So if you power up the system or to restart your application, then only persistent parameters are reloaded. And if the vendor of the camera does not support this feature, you have a problem, because then you have to set up the camera setup by hand. And this is done by MVTec for the easy parameters automatically. So this is a big advantage in the usability on the one side, and on the other side also a big advantage in the compatibility with industrial cameras as well. The next feature is the transferring images via the MERLIC communicator. That means, here we have a small GIF. In the past, you easily can pipe out any result of your MV app to the communicator interface. But now with the new release, you're also able to pipe out images on the communicator interface. This makes it possible for you to use these images for other kind of visualization or the direct channel to save the images in your quality assurance system, for example. And in the same time, we also add a new standard communication plugin called Save Images. This is a flexible plugin which gives you the possibility in the RTE mode to save the images on your local hard disk depending on the status of your MV app. And for sure you can compress the images or change the formats. So this is very helpful for the runtime environment mode. We also improved the development of so-called custom tools. So custom tools are extensions. You can extend MERLIC with the help of these custom tools to add functionality which is not included from the beginning of in the standard content of MERLIC. For that, now you can directly connect with Helcan HDevelop to the MERLIC instance and can remote debug your tool. This will help you a lot if you're developing your custom tools. We also extend the documentation. That means in MERLIC you easily can press F1 and then you have every information about how you can write your own custom tools and what is interesting to know about developing custom tools. We also extended the tool parsing information. This is helpful as well. We add the multi-language support for the quick info on the right side. So now if you change the language of MERLIC, you also can have different kind of languages in this quick info. So in some cases this might be also very helpful. And to make it easier for you to program your own custom tools, we're also providing a new programming example to give a smarter start for developing. And last but not least, we add a new AI concept tool called the segment IML Pixel Precise. On the left side, we see again one of our front ends, which shows our pill example we also have in Helcan. And this tool, based on the Helcan deep learning segmentation, we add a new example, as you can see on the left side, which called segment pill defects. It shows you how it works and gives you a smart start for solving applications with the segmentation. Labeling is already available in the deep learning tool, but at the moment the training and evaluation you have to do in HDevelop till it's available in the deep learning tool. But please have in mind, we strictly do not recommend to use these tools in the production line because there's no guarantee for stability and compatibility. But please use this tool, test this tool, and give us your feedback. This is very important for us because if we want to, if we release this tool in the next or the the upcoming releases, it helps us a lot if you feedback us if this fits to your application or if we can improve something. So please use the feedback button in the MERLIC Creator to give us feedback regarding this tool. This was, these were the features of MERLIC 5.2, and now I will hand over to Jan, who will show you the features in a practical way.
Thank you. So, hi and welcome here for the hands-on part. My name is Jan, and today I'd like to show you the newest features of MERLIC 5.2 directly in our product. Let's have a look directly into our first new feature called the Easy Params. And therefore, we have here a setup with a camera, a light, and we will start MERLIC 5 Creator now and connect to the camera. So we start the MERLIC 5.2 Creator. And then once it's started, We have here our default tool flow, and on the right-hand side here we can configure the image sources. Therefore, we go to image source configuration. We can now go on edit, and I already prepared two configurations for today, an online configuration and an offline configuration. Here in the online configuration, our main configuration, we can now select the camera. I have here on my right-hand side, and here we can see the new easy params. So we can connect to our camera and can now see easily the most important parameters like automatic exposure control. We can set the exposure time here. Immediately we get feedback, but here we want to have this value for today. We can set the gain, and we can also configure our trigger mode. So if you want to use a software trigger or one of the available hardware triggers. But we still also have all parameters option. So if you want to set a specific parameter, you can always go to all parameters and set the visibility level to all, and you can see all the parameters the camera supports. That's a really convenient way to set up your camera. By default, you get the most important parameters, but if you want to set up some special parameters, you get the whole flexibility with the other tab. So that's our first cool new feature. Once we are done, you can save parameters, and the parameters are stored persistent, as Christoph described before. Okay, and then we can directly head to our next new feature, the global context anomaly detection. Like Christoph said before, for the global context anomaly detection, we need some images to train our network, just good images. And now let's collect some images with MERLIC 5.2. Therefore, we are adding the tool image source. To use our image source in our tool flow, we can now see our image here from our camera. And next, we want to write the images to file. Therefore, we are searching in our tool library for write, and we are finding write image to file tool. We can drag and drop our tool here, and now select the destination for writing the files. Therefore, we go to our work in progress folder. We create a new folder called images, and then we create another new folder called OK, where we can write our OK images too. Then we are selecting this folder, and now another new feature with MERLIC 5.2. We can go here to additional parameters, and we can also select to add a prefix or suffix to our file name. So a specific file ending, for example, that is added to every written file. Here we add a suffix and we select date and time. And now when we are acquiring images, so I put one box of jigsaw blades below our setup. I press play, and then we can see the image is written to the folder with a new file ending suffix of the date and time. Now we can acquire another image and press play, and the images are stored. But as Christoph said before, for the global context anomaly detection, we need around 100 to 300 good images, and that would take some time, so I prepared a folder with enough images for the training. So I copy here my prepared image folder, delete this image folder, and insert it. Once again. Okay. At this point, we are done in MERLIC so far, so we can close the MERLIC 5.2 creator. We don't save our application. And we can now start the deep learning tool to train our global context anomaly detection network. So we are starting the deep learning tool. We are creating here a new folder called DLT in our work in progress folder. And then we can simply create a new project. Here we can see all the types of projects that we can create. Today we are interested in the anomaly detection, and we call the project jigsaw blade inspection, and we write it in our new folder. here, select. And we store the image path relative to the project so we can easily transfer our project later on in on a different file system. Create project. So so far there are no images in our project, so we can add new images here, add image folder, and then we can add this image folder to our project. As you can see, here we don't have only good OK images, we also have not OK images. Christoph said we don't need not OK, that's right, but we can use not OK images to improve our threshold selection. That means we are training our network only with good images, and later on we get a score for every image, and this score can be selected manually, or if we also provide not OK images, this score can be defined automatically. You will see later on. So we import the images. Now in our gallery tab we can see all the not OK images. We have here many not OK images with different defects, and we also have down here the OK images. And here it's really important that we have a big variance between all the possible positions of the switch blades so that the network learns how a good image can look like. Then we can go to our review tab. We can check our not OK images. Those are looking all right. And then for our training, we first need a split. So we split our data into training data, validation data, and test data. We click here, create split, and now we can see in the training images, we only have good images, no anomaly images. And then we are using for the validation images good and anomaly images. And for the test images, we only use good images. We create the split. Then we are done with the split, and we can create a training model. We go to create, save our project, and we can now see all the parameters that we can configure in the DLT. So we can select what image width and height we want to have, in our case 500, so a larger image width and height to get more details. So we can even detect even smaller defects. We take a 3-channel image and we use the default patch size. We can select on which device we want to train, in our case the GPU. And here also we use the default parameters. The default parameters are great for many different use cases. You may have to adjust them for some special one, but usually you can just use the default values. Then we can start our training. And what's really nice here with MERLIC, with the DLT 2210, we also improved our global context anomaly detection. So first, now the training is way faster. A training that lasts before 8 hours now takes only 2 hours. And also the inference time is around the factor twice faster. So that's nice too. Here in our training today would take around 2 hours. So that's too long for our webinar. So I will stop the training here and we will open a project where I already finished the training. So we close the DLT. We delete our DLT folder and we now copy our prepared DLT folder into our work in progress folder. Here once again we have a project called Jigsaw Blade Inspection. I open the project. We can see the training is done. So we get a validation F1 score and everything looks good. And now we can go to the evaluation tab to evaluate our training. We can start the evaluation. Wait a short moment. The evaluation is running. We get our usual inference time per image in a short moment. We can see it around 20 milliseconds per image. And we can see on the confusion matrix what's happening during the evaluation. So we get a confusion matrix here on the left-hand side. We can see all the images that are good and are also classified as good, all the anomaly images that are has an anomaly are also classified as anomaly image. And we can also see here, for example, an anomaly image that is not classified as anomaly. That's a problem. as I said before, the threshold was calculated automatically based on the all provided anomaly images and the OK images, but here the automatic threshold was not perfect, so we can still adjust the threshold down here in the score histogram. So we move the threshold a little bit. Oh, one moment. And we can see when we decrease the threshold, an anomaly image is classified as anomaly image a little bit earlier, and so the error here, the error is not found anymore. So we can also increase it, so every image is classified as OK, or decrease it, every image is classified as anomaly. But in our case, we use this value here, and now we got rid of this false positives. But now we still have false negatives. So we have two images here. Let's have a closer look. They are classified as not OK, but they are OK. And when we have a closer look now here, we can see, there's a mistake on the left-hand side. I still have two fingers on the image. And here I have some noise around the image, which should not be there. So what can I do for this? Therefore, I can go to Edit Post-Processing. So we can add a post-processing after the inference. And we can here restrict the domain, which is used for determining if the image is OK or not OK. So here we can draw a region, say from here to here to here to here and back up. We only want to use this region for the final classification, saying OK or not OK. On the whole image, the inference is done, so the algorithm is not faster by reducing the domain, but only the domain is used for the classification process. So we press apply, and now we can see all the false negatives are done. That's really nice. So far we are done now on the deep learning tool, and we can export our good model to use it in MERLIC later on. So we are here going to the training, going to export model for inference, and we are exporting the model. Best model, and in our work in progress folder. So now we are done with the DLT, and we can close the DLT and go back to MERLIC. Here I also prepared a project for MVApp for this webinar today. So we have to do a little bit less. So I created a front end in advance, and we can see it now. So I open the Jigsaw Blade Inspection MVApp now, and we can see it's a similar app to in comparison to before. I just added a front end that you will see later on. So we have here the image source and the write image to file tool. We have the camera connection, and we can now disconnect the write image to file. We don't need it anymore, and we can add the global context anomaly detection. We search in our tool library for global, and we can find detect anomalies in the global context. We drag and drop our tool here. It's automatically connected, and now the most important step, we can add a model file here that we want to use for the global context anomaly detection. So we are selecting our best model. The model is loaded, and we can see here our first image is classified as OK, as it should be. So we can see here the restricted domain. We can also see with anomaly score threshold, the threshold that we set before. And we can now test this algorithm with a model with some other defect image. So we may have a wrong switch blade on the wrong position. So we can now see the model found the defect here. And also this jigsaw blade is in a wrong position. So we get anomaly detected as output. Or Another example, maybe we have a jigsaw blade that has some kind of defect. So here we can see there's a defect, and on the final image, that's also a new feature. We can directly look on our input images and visualize input images or the anomaly regions, and we can see at the right bottom this jigsaw blade has a defect, and also this defect is detected. Okay, what can we also see here in this tool? So we see we use the internal data of the model, so the data we defined in the DLT, so the region and the score. And because we're using this data, we can't modify it here. But maybe you want to use a different score threshold because you want to adjust your score threshold. You always have the option to say use just the region, and so you can adjust the threshold, or you can say use just the threshold and you can draw here your own region that is used for the classification during the anomaly detection. So we are deleting the region once again, and we can also say use none of them. So that is one option here, and now we can connect this tool to our front end. So as I said before, I already prepared a front end that we now have to connect. So we are going to connect tool, detect anomalies, and then we go to use internal data. We connect this tool as well. Anomalies score threshold, anomaly score threshold. Here we are connecting the anomaly score. Anomaly score. And here we are connecting if an anomaly was detected or not. Anomaly detected. And then another nice feature for the image display, we can go to connect tool, connect here the displayed image, and we can now connect the region of interest to this image display. What does it mean? We can here select region of interest to selected regions and press OK, launch the front end. And when we are now, one moment, that's not correct. We also have here to set the region of interest to move, modify, add, and delete. We can now launch the front end, and we can now see that we can draw a region of interest in our front end. So we can say use only our thresholds, and then we can say draw a region and say within the front end, please only use this region here for the classification in the anomaly detection. Why would we do it in the front end? We can now imagine that we have a defect part that does look like, one moment. We may have a defect part like this here. We have a defect here, but we only want to focus on our jigsaw blade. So we can draw a region here and say, just use this region, and now the part is classified as okay. That's really nice and a good feature. Okay, we are deleting our region and we are setting our model back to use internal data. So now it's working as before, and that's we are closing the front end, saving our application, and that's basically how we can use our global context anomaly detection in MERLIC. So we have seen we can train the model within the DLT. We are exporting the model afterwards, and then we can import the model in MERLIC 5.2 and easily use it by just setting the model file parameter. That's really easy and convenient to use without writing any line of code. So that was the second thing. So the first one was easy parameters. The second one was the global context anomaly detection. And then Christoph also mentioned another nice feature. So now with MERLIC, you can also transfer images via OPCA or MQTT, and that's what I want to show you next. Therefore, we go to the runtime environment. Therefore, we define our result that we want to transfer via our communication interface. So we go here to please transfer anomaly detection as a result, and please transfer also the displayed image. So we click here on this little arrow and say add this image data type to our results. Now we can check this application, so we go to MVF parameters and results, and we can see we have now here two MVF results, and we can save this settings in our recipe file that we will use later. So we go to save, we are saving the recipe. What else do we have to do to use our MVF in the runtime environment later and to transfer images via OPCA? So we go to runtime environment setup, image sources, and we can now set our current camera configuration as default image source configuration for the RTE runtime environment. That's okay. Then we are going to the communication tab, and here we can see some new features that we have implemented with MERLIC 5.2. So the communicator is starting. We can add a new plugin instance, the OPCA plugin 2.0. And here we can, what do we have to do here to transfer images via OPCA? So first we are setting the security policy to none to connect more easily in our webinar to our OPCA server, so we don't need a certificate to connect to the OPCA server. Then we are, the most important thing, we are adding the image results to our we transfer the image results, and then we are setting the mode to free running. That means every new result is written into a variable on the OPCA server and can easily be loaded from the OPCA server onto the OPCA client. And then one more thing, we can also say image zoom mode, zoom factor, so we don't want to transfer the whole image, but only a smaller part of it to save some bandwidth. So we say maybe 20%, and then we are basically done in the OPCA with the OPCA setup. So we can save the changes here. We only had to modify a few values, and then we can start the plugin. The plugin starts, and we now are done in the communication tab. We can, in the next step, we can add a recipe. We can say import recipe and go to our work in progress folder and use our recipe that we have created before. We open the recipe and we are setting this recipe as a default one, the recipe that starts when we start the MERLIC RTE. So far we are done in our runtime environment setup. We can close it now. We can close our communicator, and we can also close MERLIC. Then, what do we have to do next? We can go to the search bar and search for RTE. And now we will find MERLIC 5.2 RTE with frontend plus communicator. So everything starts up. We are waiting a short moment. And here MERLIC with the communicator starts, so also the OPCA server starts. And we can now use an OPCA client to connect to the server and control our MERLIC vision system. Therefore, I prepared a configuration for the UA Expert. UA Expert, it's a free software, an OPCA client that can be used to communicate with the OPCA server. And in our case today, it simulates our PLC, so our process control system, for example. So we are starting our UA Expert, and we are connecting to the server, and we will see we have here on our OPCA server a vision system. Within this vision system, we have many different nodes. So, for example, the vision companion, and here for every recipe we have a job executor, and we can say start single job or start continuous. So we can put now our front end on the right hand side, our OPCA server on the left hand side, start a single job. And we can see now our image Now we put another image below, another object below the camera, and we can execute another job. And you can see we can control our MERLIC instance via OPCA. But that's just the control. We can also transfer images now. How that? We go to the Image Viewer tab, go on Latest Results, and drag and drop our displayed image into this field here. And now we can acquire another image or run another time. And we see here, every time we get the newest image into our UA Expert immediately. So it's really easy to use. You get the results in your UA Expert, can control your MERLIC instance, and that's quite convenient. That's one of our also newest features with MERLIC 5.2. But you don't want to transfer every image via your OPCA interface to save some bandwidth. Maybe instead you want to write your files directly onto the file system of your local machine. And also that's possible with MERLIC 5.2. So we are closing the RTE now, or not something. We are closing the RTE now, and we are opening our project once again. So we're going to Jigsaw Blade Inspection and opening the project. Why do you want to save the images directly to a file system? That makes sense in specific scenarios. Maybe you already have your global context anomaly detection trained and you are collecting all the anomaly images because maybe later on with the anomaly images you want to train a classifier and then use a classification deep learning model later on to get a more precise output of your application. So maybe in this case you just want to find anomalies, but later on you want to classify if it has a boxy defect, is the jigsaw blade upside down, or what kind of defect you have. So the writing is really nice for collecting images for later use. So therefore we can go to the communication tab, start the MERLIC communicator, and we can see once the communicator is started that we have here also the Save Image plugin. That's the plugin with which you can save images to the file system. So we can here say to which location we want to save the image, and we can also say just save good images or just save bad images, depending on what you want to save on your file system. Okay, that was transferring images via OPCA and saving images to the file system. Also a great new feature of MERLIC 5.2. What we have seen so far, we have seen the easy params, we have seen the new global context anomaly detection that is trained within the DLT and later used in MERLIC. And we have also seen the new image transfer functionality via OPCA or directly onto the file system. And now we have another great feature within MERLIC 5.2. Now our customers can write extension tools by themselves. So we extended the documentation for the creation process of extension tools, and therefore you can simply press F1 within the MERLIC 5 creator, and then we have a new section here called MERLIC Tool Development. Within the MERLIC Tool Development, you get the whole development process explained, so it's easily to follow. And you also get a tool template that Christoph mentioned before. It explains how you can, an extension tool could look like. So the documentation is really well written. So have a look here if you want to write your own extension tool. But what could you use an extension tool for? Here in our application today, it can happen that every box is in a slightly different position. And you may want to align the region of interest to the box. So we want to input a region of interest, an interactive region of interest, and not a fixed one. So we say here, just use the thresholds, and we may now want to create an extension tool that detects the box and then gives a region of interest to our global context anomaly detection tool. This would be possible directly with MERLIC, but in our case today, we create an extension tool to show how simple it is to create an extension tool. So therefore, I prepared an extension tool. In our template folder, I copy the extension tool to our work in progress folder. And now we have a look into this folder here. How does the extension tool look like? So usually you have an HDevelop procedure library. So in this procedure libraries, all the procedures that are used within the tool are listed. Then we have a test procedure to test our test script to test our procedure library within HDevelop. And then we also have a documentation folder that contains the documentation in any language and then is shown later on the right-hand side of the tool. How does the procedure look like? Let's have a look in this procedure today. Actually, an extension tool can be really simple. It's a procedure with inputs and outputs. We have here an image input, a region output. We have to give a tool handle that is required for every extension tool, that you have one input control parameter called tool handle. Then we have a threshold that we can give in, and we get a region of interest box out. And here we have just a simple, just some simple operators that are determining the smallest rectangle of the region and then creating a region of interest box. So it's really a simple extension tool. And how can we use it now? Therefore, we have to define in which location our extension tool is. So we are going to our app data roaming MVTec folder, and here we have the MERLIC 5 ini. And in the MERLIC 5 ini, we can say our extension tool is in the folder Jigsaw Blade Inspection Work in Progress Extension Tools. So we are saving the location here. We are closing our creator, saving our project. And now the next time we start the MERLIC 5.2 creator, we can see a new section where all the available extension tools are listed. So here in the tool library, we see here, down here, additional, and we can see our new extension tool. Now we should open our application from before. And we can also add this extension tool here to a specific section if we want to. In our case today, we like our extension tool at the bottom of the tool library. So we can drag and drop our extension tool here. And you can see an extension tool looks like a normal MERLIC tool. We can simply adjust our threshold. So in this case, this value looks quite good. On the right-hand side, we have the documentation, and in the bottom, we have all the results of this specific tool. So for us today, we want to connect our output region of interest box to our global context anomaly detection. And we can see now when we are moving the box slightly, the region of interest is always aligned to the box. That's a cool extension tool. As said before, for this simple tool, we could do the same functionality with the internal tools of MERLIC, but here just for visualization. Okay, I hope you have understood how nice extension tools are. And let's summarize one more time what we have seen today in our presentation. So therefore, we are going back to the summary. What we have seen first are the easy params for easy configuration of the camera. Then we have seen our new global context anomaly detection that was trained in the DLT and then used within MERLIC. Then we transferred images via the communicator interface, and we used the communicator to save images to the file system. And last but not least, we also have seen our new extension tool interface that is really easy to use and gives you even more flexibility within your MERLIC MV app. So here we are finally at the end of the technical hands-on presentation. I hope you liked it. And now we have a survey for you, so please go on to this link here. And we have some questions if you liked or how you used our features that we have released with MERLIC 5.1, so about our last release. And we also are interested how you like our new features that we have integrated in our new release MERLIC 5.2. So please take a short moment and fill out the survey. Thank you for listening and goodbye. Thank you.